Hello everyone. In this particular video, we are going to see how to do rectifiers practical in the lab. So in that, we are going to see rectifier circuit, half wave, full wave, and bridge rectifier. So before proceeding to the lab practical, or we can say lab video, this is the half wave rectifier. You can see here, this is a 230 volt 50 hertz AC mains. So it is stepped down to a smaller AC voltages like 9 volt, 12 volt, or 18 or 15 or 21 volt. So the smaller AC voltages is available at A and B. You can see the secondary of the transformer, and then it is provided to the diode. So that diode will act like a open switch and closed switch according to the which cycle positive or negative is going, and according to which we are going to observe the voltage at the output of this rectifier. So you can see here in a positive cycle, what we are getting, the diode D1 conducts and we are getting a positive cycle in here. For negative cycle, we are not getting any kind of voltage, so we are getting zero voltage. And again for the positive cycle, D1 is conducting. So in this way we are getting the value of this particular voltage available, and that is a pulsating. So we can do it like just a register in there, so we can calculate the voltage, AC voltage, DC voltage, to calculate how many ripples are there. And then we can use capacitor in here, so that capacitor will act like a filter. So that capacitor will tell us how the ripple is removed, or how what will be the value of the ripple frequency, ripple factor, after the capacitor is inserted in here. So let's look at the live video from the lab. So this is half wave rectifier. So you can see here, I have connected half wave rectifier and I am measuring the AC at input, and now I am measuring AC at output. So you can see here the AC at output is 7.15. If I measure DC, it is 5 point. These two readings are necessary to calculate ripple factor. So you can see here, without C filter we are doing the experiment, where we are getting AC output at 7.15 volt and DC output was 5.74. So from that, if we calculate the ratio of it, it is 1.24, and if it is in percentage, it is 124 percentage. Standard it is 121. We are very close to the standard reading, the half wave rectifier circuit. So we'll see how the with C readings are. So I'm closing the supply. I'm going to connect the resistance one terminal to the capacitors one terminal, so that the capacitor will be in parallel with the resistor. So we are having a filter circuit inside this rectifier. So I'm going to connect the resistance other terminal to capacitors terminal, so it becomes a parallel. Now we are measuring the voltage, DC as well as AC. So I'm going to measure the AC voltage first. It's on. It is showing like it is varying, so we can say it is a zero, so it is not stable at all. It is in that indicates 0 L, and the DC is 16.54. With C filter, what we are having, the AC output is actually 0 and we are having DC output is equal to 16.73. So if we calculate it, the ripple factor is actually 0. We can say in percentage it is 0, and standard it also 0. So with C, we are not having any AC component at the output of the rectifier. So we can see, uh, with C filter, the half wave rectifier is rectifying the AC signal into a perfect DC signal. The second rectifier circuit is a full wave, that is also called as a two diode rectifier. You can see here, the center tap transformer is used, and in that center tap transformer they are connected in a such a way that the center tap terminal is connected to RL resistance, the last terminal, and the RL resistance first terminal is connected to the cathode of diode D1 and diode D2. The magic of this particular rectifier circuit is that the both cycle get rectified. In case of half wave, only the positive cycle was rectified, but in this case both cycle get rectified. You can see here, for the positive half cycle, D1 is conducting, and for the negative half cycle, D2 is conducting. This is due to the fact that at A, whatsoever the signal at A, it is 180 degree phase shifted at B. Okay, so that's why for the positive half cycle D1 will conduct, and for negative half cycle this will be the positive for D2 and D2 will conduct. So in this way we are getting both cycle at the output of this rectifier. Let's look at here. I have connected the AC input is 13.69 volt. This is actually a 2 diode rectifier where we are using 1 and D2. So I'm going to measure the output. So output AC is 2.88 volt and the DC is 5.43. From that we can measure ripple factor. So you can see here without C filter what we are having 2.8589 and 5.43. So according to that the R is 0.53. So we can say in percentage is 53 percentage and in standard it is 48%. With C filter, so I am going to connect again the same procedure. RL's one terminal is connected to capacitor's positive terminal, or we can say one terminal, so that it will become across the resistance RL, so it will be in parallel with resistance RL. So I'm going to connect the next resistance terminal to the capacitor. So you can see now this is with C rectifier. So I'm going to connect the positive probe of the multimeter to resistance resistance RL's resistance 1 terminal, and the next is connected to the next terminal. So just a moment, I'm going to connect it positive so that we can see the multimeter. So look at here, I have to make it on. Then we are going to measure the DC voltage, or we can measure first of all the AC voltage. It is indicating like 0, again same 0 L some readings, so we can consider it to be at 0. And then DC, this is 8.6162. Having the AC output is fluctuating and it is 0, and at DC we are having 80.62. So the ripple factor is actually 0. So in percentage it is 0, standard it is also a 0. So we'll go for the third rectifier circuit, that is called as a bridge rectifier. So you can see it is some sort of bridge over here. We can say that's why it is called as a bridge rectifier. So again 230 volt 50 hertz AC mains step down transformer, and again what we are having now, so let me erase. So what we are having for the positive half cycle, at A it will be a positive, at that time the B will be negative. So what will happen when A is positive with respect to B, diode D1 and diode D2 will conduct, as the current will started flowing from this direction and it will go towards the B is at the negative side. We can see for the positive half cycle D1 and D2 is conducting, and for the negative half cycle at that time it will be negative to A, but at that time it will be positive to B. So at that time the dotted line indicate the current direction, so it will be going from D3 D4 towards the A. So we are saying that the next half cycle, negative half cycle, is rectified by the diode D3 D4 and it is continue for forever. So how to calculate the ripple factor of this particular circuit? Just look it in here. So let's look. I have connected the 4 diodes. This is a bridge rectifier. I have measured the AC at input. You can note down the AC at input. Then I am going to measure for the ripple factor the value of AC at the output. So this is without C, 5.8786. And then I am going to measure the DC. This is 10.9293. The ripple factor without C filter for bridge rectifier is AC output is 5.86 and DC output is 10.92. So if we take the, so in percentage it is 53.6, standard it is 48 percentage. So to have a C filter, again the same procedure as like half wave rectifier and a 2 diode full wave rectifier. What we have to do, we have to connect the filter circuit. So I am going to just uh, switch the off socket, then I'm going to just remove the multimeter from the connection. I'm going to take a wire that is connected in between resistance RL's one terminal and capacitor. Then again I'm going to take the next cable. I'm going to connect it in between resistance RL's next terminal, the capacitor. So now the circuit is perfect for the uh, with C filter bridge rectifier. What we are going to do, we are going to measure the ripple factor of this bridge rectifier. So let's look in here. We have to measure actually AC and DC. So first of all, we are going to measure, keep the circuit on, measure the AC. So I'm going to measure the AC first. It is again indicating like some readings 0, and I'm going to go for DC 16.83. With C filter, we are having AC output that is equal to 0 because it is having a value that is fluctuating around a 0. DC output is 16.84. If we calculate it, it is 0. Standard it is 0%, and we are getting a ripple 0% in the bridge rectifier practical.